Yinglin. I'm now currently a PhD student at Imperial College. My research topic is about machine learning and deep learning. I know most of you is working on SALM or something, but my major is about face analysis. You know, just face detection, face recognition, and something like that. Okay. You see the slides here? What's wrong? Okay, I think the slides is okay now. Okay, let's continue. So, today I want to talk about Keras. Keras is a very useful deep learning library for prototyping. You know, as a researcher, the most important thing for you is to just implement your algorithms fast enough so that you can publish the paper ahead of other people, other researchers. I think that's the priority. I think that's the most priority for most scientific researchers, especially in computing or computer science, or just like you in SALM, sorry. Yeah, so I think Keras is the most useful library for prototyping your initial ideas. For example, if you are tackling with some image problems, you want to classify different classes, and I think you can just use Keras because you don't have to do any pre-processing, or you don't have to write the framework from scratch. You can just use one line, two lines to implement to see if it's work, and then if it's working, and you can do a further step. Okay, so let's continue. Okay, today I would like to talk about 4 parts about Keras. Can you see the slides is now moving to the next one? Yeah, the first, okay, I think you can see it. Yeah, the first part I would like to talk about why on earth we use Keras. And the second part, I'm gonna show you how Keras working pipeline is, and how should we implement a deep learning network just by Keras, and how to do it simple and elegant. Okay, and for the third part, I want to introduce you some functions, some utilities, which I found most useful in the past 1 month or 2 months for me, because I think you are just like me. You do a lot work with images, and I think it's very tedious, it's very boring to pre-process the images before you can start training your networks. And Keras offered many useful functions for you to handle the pre-processing steps. So you can see it's very elegant. You can just use one line to do some very hard, very tedious pre-processing. And for the final part, I'm gonna go through with a detailed example using Jupyter Notebook, which was IPython notebook. Okay, I can show you a basic example using MNIST for digit recognition, and I'm gonna show you a more difficult problem for classifying dogs and cats. dogs and cats using some existing deep learning models, which is often referred as fine-tuning an existing deep learning neural network. Okay, so far so good. Let's get started. Let's now continue to the next slide. So why do we choose Keras? Among so many deep learning libraries, why do we just choose Keras? I think to answer this type of question, you can just look at what giant companies do. Giant companies like Google, what they do with these libraries. Okay, so I think it's just the news from this month that TensorFlow 1.0 is released, and Keras is integrated into the TensorFlow 1.0, which means that you can just you don't have to install Keras separately after you have installed TensorFlow. You can just import in Python. I mean, you can just import TensorFlow, and then from TensorFlow.keras, you can just import Keras, and you can use every functions Keras offer in just one line. Just import after you import TensorFlow. So I think in Chinese speaking, you can just say 他爹很好，他爹很牛, because the author is originally from Google. So the relation between Keras and Google is very close. So you will not get it wrong if you just follow Google. Okay? And okay, you can see it here. I got some example codes. You can see you can interchange between Keras and the TensorFlow seamlessly without any modifications or changes. You can just import TensorFlow STF and import Keras, and you can see this line here. Let me use a pen here. This line here. Can you see this drawing? The image is defined using TensorFlow commands, but the network, the fully connected layer, is defined using Keras. Okay, so you can just use two libraries in your script, in your network. Okay. All right, so far so good. Can you just type any words so that I know you are listening? Because I saw some people are coming, but you don't give me any feedbacks. So I don't know if I'm clear now. Oh, always remember this saying, yeah. KETE combo rocks, which means their combination is awesome. Yeah, this saying is very popular in the machine learning community. Okay. Oh, good, Tyler. Thank you. Okay, let's move on. Here, the second reason we use Keras is that it provides a very high-level abstraction of some nasty functions for training deep learning networks. For example, if you have defined the model and you want to train the model, you want to train using a batch SGD, you can just, or you want to change your optimizer to IMS prompt, you can just use two lines to do it, and you don't have to define these optimizers by yourself, or the loss function, or the metrics you want. You can just write it in your compiling stage. Okay, and if you're gonna train it, you can just use one line model.fit here. Model.fit, and your training data, your training label, and the batch size you want, the epochs you want. Okay, so it's very simple and clear and straightforward. You don't have to use the original Python generator. You don't have to define a batch generator to train a batch every time in every for loops. Okay, so am I clear? Okay, because the high level abstraction is very good for you to prototyping your network. As I said earlier, the time is always the first priority for researchers, because you want to get your paper published as soon as possible. So if you can do it very quickly, you are more likely to get your paper published ahead of other researchers. Okay, and the third reason we use Keras is that the author is very awesome. I don't know how to pronounce his name because he's a French, I think, but he produced Keras, which is already very amazing, and then he write a very, very, very good document for you to refer to. In the document, it provides very detailed descriptions about the Keras functions, how you can use them, and how you can define your own models. And this is I would like to say something about MXNet. Have you heard about it? MXNet, because I have used it before, and I think that the document they wrote is terrible, and it's very difficult for newcomers just like me in the deep learning world. So I think as a newcomer, or you wanna try something about deep learning, Keras is the first choice you can make. Okay, so far so good. Okay, I think that's all for the first part, and let's move on to the second part. Let's just shut up and show you some code. I want to talk about something about the pipeline, how models are generally defined in the Keras setting. Okay, the working pipeline of Keras consists of 4 different stages, and I'm gonna talk about one by one. Okay, now let's move on to the first stage. It's model definition. I don't know if you have tried Diano or just the original TensorFlow. I think in defining a network, you have to, write a lot of code. That's what I did in the past during my master thesis. And now, after I found TensorFlow, after I found Keras, I can use just, you can see the example here. I can just do it using the building blocks it provides, and just define the dimensions of the fully connected layer, the activation function I want to use, or the output function like softmax I want to use. So this is simple and elegant as far as I know. And you can just say, wow, deep learning is easy after you have tried Keras. I think everybody who have tried Keras can say this, but we both know that deep learning is not just about building blocks, but it's still very good for newcomers do some, to play with it for a bit. Okay, let's continue to the second part of the pipeline. It's about model compilation. In model compilation, it's more like you specify the learning rate, the loss function you want to use, and the metrics you want. For example, in multi-class classification, you want to use softmax as your output, and you calculate the final softmax loss to start the back propagation stage. And then, but in Keras, you can just use one line to specify. You don't even have to define the optimizer if you want to use the default setting. For example, if you just pass the string, and then which is SGD, just SGD string, it will use the default setting of SGD. For example, the default learning rate is 0.01, I think, and the momentum is about 0.9. It will use the default setting when you start training your network. So you don't bother to define an optimizer yourself. But you can do it, of course. You just do one step more. You import the optimizer you want from the Keras start optimizers, and then you specify the learning rate you want. Here, it also uses the default settings, which means you don't have to use it. You can use just SGD. You can use just SGD, the string. You can just input the string. Okay, of course you can change here to 0.1 and 0.01 here. Just do it. Try it parameter. Try any parameters you want. Okay, that's for the compilation. Let's move on to training. Oh, training is the most elegant part. It's my favorite part because you can just use fit. Yeah, it's very straightforward, and the word fit means everything to me. Very intuitive, and I used to use Theano, which means in my old days I have to define a for loop first, and then I have to define a batch generator or something, and then I start reading the training examples, training batch to the batch generator, and then a for loop again or something, which is quite nasty. But now Keras is a lifesaver. Yeah, I have to admit it. So now you can just use just one line to ask the model to start training, and it will also print some useful information that you want. You don't have to define them yourself. Okay, let's move on to the fourth part. Fourth part is about prediction and evaluation. You can evaluate your performance as here to get the loss and metrics in a class. As we defined in the compile stage here, you can see we asked the network to measure the accuracy and the loss. So you can, after you have trained your model, you can evaluate the loss, the softmax loss, and the accuracy just using model.evaluate on your test data. And still, you can specify the batch size here. Okay, this is for evaluation. I think evaluation is more like when you are doing validation, when you don't have, when you still have the labels on your validation set. And now it comes to the prediction. Generating predictions is more practical. It is used in the practical settings when you wanna deploy your methods, your algorithms in some platforms you want. For example, some robots or the mobile phones. You can always use just predict class using and input the the test data, the test point, and it will predict the classes with a probability distribution over all possible classes. Okay, this is, I think that's all for pipeline. Are you clear? Is it clear now? Let me see if you got some comments. Okay, nobody. We got 1, 2, 3, 4, 5. We got 10 people here. Can you say if you are still listening? Can you tell me? Yeah, I hope my accent is not so terrible. Okay, let's move on. Next, I wanna introduce some utilities which I found useful in pre-processing images. The first one is pre-processing module, and the second one is application module. In pre-processing, it provides, let's just continue. In the pre-processing module, Keras provides useful data augmentation methods for sequence, text, and image data, which means you don't have to do some pre-processing yourself. You can just call the libraries to do it for you. Let's look at some examples. For example, if you wanna pre-process your images, if you wanna train image recognition networks, the images have to be pre-processed. Of course, yeah. So some procedure we'll go through is flipping your images, so that if you got a cat here, sorry about my drawing, a cat here, and I think okay, let's just say it's a person. If you got 群主, okay. If you got Fu Qiang in your picture, and then after flipping, I think it's still Fu Qiang, right? It's still Fu Qiang here. So this way, they are the same. They are the same. They are the same for the same person, for Fu Qiang, but for your deep learning network, they are totally different. So this way, it implicitly increase the size of your data. So you don't, because as we all know, collecting data is the most important, the most difficult part for supervised learning, and it's very expensive to collect more and more data. So using some augmentation methods, you don't have to collect so many data. Okay. And next is shearing. I think it's difficult to draw shearing, but you can picture something like this. You can picture something like this. Yeah, it is sheared somehow. Shear. And rotation, of course, after rotating 90 degrees, this still Fu Qiang. This is still Fu Qiang, right? how to draw. Okay, yeah. After rotating 90 degrees, it's still 富强 there. And rescaling, I think rescaling is the most important part in pre-processing, because when you get the original image is always about 0 to 255, and you can just you will always have to rescale it to 0 to 1. For example, 0.5 or something, 5 to 3 for 1 pixel, right? For 1 pixel intensity. And so now you can see, if you have to do all this data augmentation yourself, your program is gonna look very long and very messy. Yeah, at least for me it is. Yeah, maybe some of you are very good at coding, but it's not for me. Yeah. Okay. So when you got Keras, you don't have to bother this. For example, in Keras, when you are doing with image, you can just using this function here, this class in the pre-processing library. It is called image data generator, and here is the code for how to use it. And we're gonna talk in more detail in later examples. But now I just want to show you how simple it is to pre-process your data. It's about rescaling. You can just specify what a rescaling rate you want to use. And the shear range is the angle you want to shear. And the zoom range is about zoom in or zoom out. Yeah, and horizontal flip, just like I said here. Okay, it's gone. Horizontal flip is just flipping your image somehow. This way, it will do it automatically. Okay, and this is for training stage. In testing stage, you don't have to do so much pre-processing. Sorry, what you have to do is just rescaling, yeah, to 0.1, to 0 and 1, between 0 and 1, yeah. So after you define the generator, you can start flowing your images using this method of the class. You can specify the folders which contain your images, and you can specify the resize shape you want for your inputting image, because original image can be like 4:2 or 2:85, something like this, but you want them to be resized just 150 times 150. You don't have to do it. All you have to do is you put the images in the folder and call the Keras function here. Okay, same for the validation generator, and then you use fit generator. It will start just training your network automatically. Okay, and okay, oh yeah, here you can see the class mode here, because in classification you always have to specify the classes for each class, and in Keras you don't have to do it yourself. You just put the folders, the corresponding images in its folder, and then Keras will read each folder and specify the folder to be one specific class. For example, we got a folder which contains dogs images, and like dogs images, And we got another folder which contains cats images. So after you have put them in the folders, you can just specify the class mode to be binary. So it will Keras will automatically label all these images, all these stock images to be 0, class 0, and all the cats to be 1, to be class 1. So yeah, that's another plus for Keras, for using Keras pre-processing library. Is that clear? So you don't have to, for example, you don't have to specify the labels for every image you imported. You can just ask Keras to do it for you. Okay. Still online, everybody? Still following? Okay. Let me just continue. Okay. Another important library is Keras.application. This library is useful because they provide deep learning models, pre-trained deep learning models for you to just use it, because they got alongside with pre-trained weights. I think this is the first thing you can do if you want to use deep learning models in your work, in your tasks, because training a very complex deep learning neural network is very difficult and it's time consuming. You can always use pre-trained models to help to see if it's working for your problem, for your task. For example, here, if we wanna use the VGGNet just for a feature extraction, you can just do it simply by importing the VGG16 here and pre-processing image and application VGGNet pre-process input. Just import some functions from here, and you can just define the model like this. So this way, the Keras will download the pre-trained VGG weights for you. And also, you can see here the include top. This parameter specifies if you want to include the fully connected layers. For example, you can see all deep learning networks consist of, for example, these are convolution layers, and followed by some fully connected layers, FC here, and then the output. Yeah, most deep learning networks look like this. So if you specify this include top parameter to be false, and the Keras will just import this part for you, just the convolutional layers. So these layers can function as a feature extractor, and you can just use it to extract features from your image. And you can later train a fully connected layer for classification if you want. Okay, because after you have got these features from the convolutional layers, you can do a lot of things other than classification. You can do clustering. You can also do regression. Yeah, so you don't have to just use it for classification, because now you got features, and features can be used for any applications you want. So let's go back to Keras. For Keras, you don't have to. They include all the existing state-of-the-art deep learning networks for you. For example, they also got a residual network or just GoogleNet or ResNet. These networks are all included in this library applications. So do check it out. Do check it out. It's gonna be very useful and it's gonna save you a lot of time. Okay. I think okay. Let's all for the theory. It's not strictly a theory. I think it's just an introduction. And now I'm gonna go through some detailed example for you. And I got my Python notebook here, if you can see it. Let me exit this first, and then drag it here. Can you see my notebook here? Hello? Can somebody tell me if you can see it here? Hello? Still there? Okay. Anyway, I just continue. Okay, this notebook I will share later after this presentation. So I'm gonna show you some practical usage of the Keras library. Okay, first I just import some. First, I'm gonna introduce just a simple artificial neural networks without convolution or something more advanced. Just a simple neural network. So first of all, I import these libraries here, and you can see from Keras also provide data sets. Some the most useful data sets are all included in this library. And you can see here, I import sequential and module. These two are both used for defining the network. And from the layers, you can import the layers you want. And the optimizers, now I use IMS prop. You can also use just SGD. Okay? And some utilities you will see that later. And this line is somehow important because in TensorFlow and Theano, Keras supports two libraries, as you may know. It supports TensorFlow, but it also supports Theano. And the problem is the dimension ordering in these two libraries is different. For example, you see it. For example, for an image in TensorFlow, it's like what? It's like 64, 3. Yeah, the last 3 means it's an RGB image, and the 64 is the rows and the columns of your image. However, in Theano, the ordering is like this, and the channel goes first. This one is TensorFlow or image ordering. Yeah, so you can always check if you are using the correct image dimension using this backend to set your ordering as TF, which means TensorFlow. Okay, and this cell is for the setup, and then we're gonna see how to do data pre-processing without Keras. I mean, you have to do it yourself now because you may not see much difference, much hassle in this simple data set. That's because MNIST is just a very small, very simple, and well pre-processed data set. So you don't have to use Keras to pre-process it. Okay, now you can see I load this data to my four arrays, and then you can see here the shapes of these arrays are printed here, and you can see here it's 28 by 28 image, but in fully connected layers, because now we don't use convolutional layers, so we have to flatten it to be 784. So I just reshape the training data and the testing data for the network for the fully connected layers to take. Okay, and then I change the type of the training data, the data type to be float 32, and then I rescale it to be between 0 and 1. So now you can see I got 60,000 training image, which is huge, and 10,000 testing image. And then it comes to specifying the class models, class labels. Yeah, because you can specify it yourself, because you can see here up here the original data, the original testing data provides only the number of the digits. For example, the digit 0 comes with the label 0. But for your softmax layer to output a probability distribution, you have to change it to a binary vector for 10 dimension binary vector, like I said here. Yeah, for example, 6, you have to make the numbers the number 6, the sixth element to be 1 and the others 0. This is a label can be taken for the softmax layer. So now I just do it manually here to categorical. Now you can see that the Y chain dot shape becomes this 2D matrix. Yeah, because now each row of this matrix is a binary vector. Okay, so far so good. Now we come to the model definition. The model definition, just like I said, is just like building blocks. Okay, so we got 512 fully connected layer here, and the ReLU layer, the dropout layer, and the other fully connected layer. So here we just got two layers, two hidden layers before the softmax output layer. After definition, you can check your model just by printing out the model.summary function, the method here. As you can see here, it prints the summary of your model, which is very clear and very neat. You can just see your parameters, the number of your parameters in this in this network you have defined. And I think, yeah, we only got two simple fully connected layers, and the number of parameters has already reached, I mean, which one? 600,000 something. Wow, this is gonna be huge if we use a very deep network. Okay, the second stage, remember the pipeline. After definition, you have to compile it. So I just use the model.compile to specify the loss I want, the metric, which is accuracy I want, and then the optimizer. As I told you, you can just use a string like RMSPROP, and the model will use the default setting for this optimizer. And then after compilation, you just train it using the .fit. Okay, I don't want to train it here, but you can see I have trained it and the result is good just by 10 folds, just by 10 epochs. The accuracy is already 99%, over 99%, which is very, very impressive. Okay, and this example is easy, and what I want to show you is you can always monitor the training process during training, and you can check after training. You can check if you have forgotten. You can check your parameters you used during training. I think this part is very important for you to write clearly in your paper, in your publishment, for other researchers to reproduce your work. You have to specify these settings very clearly. And if you want to plot the losses during training, you can just use the class here. It's a dictionary, I think. It's a dictionary in Python. You can get the accuracy, the loss, the validation accuracy, the validation loss in every epoch. So for the 10th epoch, the accuracy is over 99%. So for this simple example, what I have shown you is just how you can define the model and how you can compile it, how you can monitor the whole training process. Okay, so after training, if you want to do some validation on your validation set, you can just call model.evaluate, and in this tuple, it will produce the test loss. I think it's loss here, the test loss here, and the testing accuracy is over 98%, which is quite unrealistic. You will never get 98% in practical applications. It's too difficult. Yeah, from my perspective. Okay, that's evaluation, and then the prediction. Let's just randomly pick one test example. For example, if you got this 7, here, we can see by our eyes it is indeed 7. But let's see if the model can produce the accurate prediction. So here you can just call model.predict and input your testing point. Remember, you have to flatten it, because now we are using fully connected layer. You cannot input just the 28 by 28 image. You have to flatten it to a 1D array. And then the label of the testing sample is 7, of course, we can see it. And then we can see the output of the softmax layer. You can see here the output is a 10-dimension vector, which represents a probability distribution over 10 classes. So we can judge that which one is the largest one. I think just the 7 is almost 1, which means the model is 100%. The output is 7. The testing example is 7 now, and you can just use argmax to transform it back to the digit. Okay, so far so good. Now we have finished the simple example. Here comes the most important application here, which is a very practical problem for classifying cats and dogs. As I said, if you wanna use Keras for classification, for classifying images, what you need to do is just to put images in the corresponding folders and nothing more. You don't have to specify, you don't have to resize it, you don't have to rescale them. Okay? Keras will take care of this for you. So in the setup, you can see I just create a data folder and create a cats folder and dogs subfolders. And I put the cat images into these folders and to put the dogs images into their folders. So in summary, our directory structure will look like this. In my data, in the training subfolder, I got a dogs subfolder and a cats subfolder. Okay, and then for the validation, I also got these 2 subfolders. So everybody clear with this setup? Now let's move on. Let's move on to start doing deep learning stuff. Okay, just as done previously, we just import some useful functions, some useful classes from Keras, and then I specify the the training and the validation director, and then I specify the training sample, the number of training samples I got, and the number of validation samples, and then the number of apples I want. Okay, before we start training the model, let's see how to do data augmentation with image generator. So from here, I import the generator, image data generator, and I want to rotation. I want when Keras import this image, it randomly rotate 40 degrees and do some width shift, do some height shift, and do some flipping. Yeah, so I just want to show you how Keras do this. So let's see the original image. This one is here, and then after augmentation, let me zoom in out. It will do just the Keras library will do it just like I specified, so such that the original image is randomly rotated and randomly flipped each time during each epoch. Okay, so this is the result from the image data generator function. Okay, now let's specify the true generator I want to use in my realistic training. So now I just rescale the input image and share it and zoom it and do some flipping. Okay, this is for training data. And for testing data, I just rescale it. Okay, and then we specify two generators. And remember the class model? Now we only want to classify cats and dogs, so we just use binary. Okay, and if you run this cell, it will output how many images they found for either generators, for both generators. Okay, after you have specified the generators, you can start training. You have many choices of training a deep learning neural network. For example, you can just start training a customized CNN from scratch. We just use a very simple, just three convolutional layers, and then just one fully connected layer, and just one output layer. And then, as usual, compile it, and let's see the summary of this network. Wow, now the number of total parameters is over 1 million, I think. It's over 1 million. And then we can just train it using fit generator method. And I'm not going to train it here, but you can see as I trained, Keras outputs the training process for me. And you can see till the end, after 50 epochs, you can see I got validation accuracy of about 74%, which is already good, I think, because we just randomly use some network, and we don't bother a lot with the parameters. We don't do much modification to these parameters. Okay, let's do something more advanced and more general, because many researchers have published their deep learning models, and we can just use them as a feature extractor for our problem. So let's see how to use it. And first of all, let's import the net I want. You can import VGG16 just like me, and you can use residual network. You can use Google Net. Okay, and then you specify an input tensor. This tensor is for the size of your image. You can specify because for existing deep learning networks, they use different sizes of input images. So if you want to specify yours, you can just add a input tensor here, and then in model definition, you can specify the input tensor to be your input, and then include top to be false, which means now the model only contains the convolutional layers. Okay, as usual, the image generator, and you can see here, I just use the predict generator here, because now I just want to use the pre-trained model, and I don't want to change the weights it comes with. So I just use it to predict my images, to extract features using the pre-trained convolutional layers. So I will get the bottleneck features from the training data, and then I save it to the directory, okay, for later use. And then same for the testing, for the validation data, I can extract its features. And after you have these two features from the training and the validation data, you can just train a simple top layer to classify them. You can see here, I load I load all these labels, okay, and produce. I load this data, these features, and then produce some labels attached to them, and then I just define a new model here, which only contains one layer. This is very efficient because you only got one layer, so you can see the training speed will be very fast because now you have extract all the features. Now you have to do is to classify these features, so it's gonna be fast. So you only need one fully connected layer, and then compile it as usual, and then fit it using our extracted features. And then you can save this. You can save the top layer, the weight of this top layer, if you want. So if you look at the training process here, the training time for each epoch is, except for the first one, is always 0. It's because it's very, very fast to train just one simple layer. And now you can get a 89% accuracy for our problem. So this is amazing. Yeah, this is amazing because we just use a pre-trained model trained on image recognition datasets, and then we just use it to extract the cats and dogs features, and then just one simple fully connected layer, and we can reach 89%. Okay. So let's come to the final part. I think 89% is you may not be satisfied with this accuracy. So we can train the whole network together and just use the pre-trained model as our weight initialization. And this way, the network is more likely to find the global minimum. So because this initialization is very important, and poor initialization will lead the network to converge to a local minima. So if we use a pre-trained model as our initialization, we are more likely to find a global minimum. So let's see how to do it. Okay, so let's specify the input tensor, and as usual define the model using VGGNet and including the weights. So now we can specify here the VGG input to be the model input, the VGG output to be the model output, and then we add some top layer here. We first flatten the output from the last convolutional layer, and then we add just one single fully connected layer, and we add one dropout layer, and we add the output layer. So after all this setup, you can just define a model like this using the model class to specify your input, which is the original input of our VGGNet, and the output to be the top model here. And then you can just compile it using the optimizer you want, and then fit generator here. As you can see, I think it's still training because I started this morning and it takes time. But you can see the validation accuracy. The validation accuracy already reaches 90, 96, 97, 95%, and the training accuracy is over 99%. Okay, so this is how to initialize our neural network with some pre-trained model. I'm gonna stop here. So I think that's it for my That's it for my sharing today. I hope you enjoyed it. And thank you very much, and sorry for my English accent, because it's very difficult to talk for 1 hour in English, and I have tried my best. So that's the wrap up, and thank you guys. I hope you enjoy it, and I will upload this slides and the IPython notebook to Fuqiang. Okay, so I'm gonna stop here. Thank you very much. Bye bye.